back in the day, Rio was, oh gosh, how do I say it? Frowned upon, I guess.
Really?
By old school mechanics and technicians and engineers, because it was that newfangled thing.
Oh.
And the technology has evolved to the point where it's a very commonplace thing now. I guess enough of the old engineers retired and the new guys came in and, much more apt to use newer technologies. What's really scary is Rockwell has worked with their partners, and they have Rio to the point where you can actually do SIL 2 safety or Wi-Fi.
I have no idea what you just said.
You know what Wi-Fi is?
I know what Wi-Fi is. The first
You know
part.
what safety is?
No. Like regular safety?
Like machine safety.
Oh.
Where you have to have light curtains and
Cages.
IOs.
Safety devices and
Yeah.
mechanical. Okay, I'm tracking now.
e-stops and, dual circuit control and all kinds of
Okay.
stuff.
Oh, you can do over the Wi-Fi now. Yeah. Okay.
Yeah, you can do it over Wi-Fi now.
Oh, well,
That makes me nervous, because I'm old school enough that I can say, okay, yeah, Rio, no problem, but you talk about safety, I want that sucker to be hardwired. But I want to know without a doubt that if I break that wire, it's going to stop.
I think we do safety since we do so much with the computers nowadays with,
Well,
you know.
those are safety controllers that you guys use, PLC3. That's why it's red.
There would have to be like, you could probably use that, but you have to have like a manual safety too.
You would think, but you don't. Yeah, it is just Wi-Fi.
Is it because of that IoT thing? That's the new.
Not so much. A lot of places do use IoT because it's a very low power, low overhead way to collect data from the field. But I wouldn't trust any IoT device that says it is capable of safety.
Yeah, because it gets squeezed.
I'm kind of with you. I'm like,
Yeah, IoT devices are, you should assume that they are inherently vulnerable, because the firmware that runs on it, well, first of all, the processor itself is not sophisticated enough to be able to do true SIL safety. So, and the people that are writing firmware for these are average Joe in their basement, and they're uploading it to GitHub, and so if you're just trying to collect data from the field, how much pressure is in that tank, or what's the level, flow rate through this pipe, things like that, it's okay. But anything that it is safety, I would steer well clear of IoT. Okay, so what are Rio? Notice this every one of these slides says legacy on it.
mm-hmm.
What we're talking about now is going to be primarily the older technologies where you have, well, there's dozens of them, DeviceNet,
Profinet?
Profinet, Profibus, thanks, good with that. Profinet, Profibus, Can Open, BACnet. BACnet is primarily HVAC. Just dozens of them. Some of them are a lot more popular than others. Nowadays, though, just about everything is run over Ethernet IP.
Mm-hmm.
Fortunately, for those older systems, whenever you need to upgrade the control system for it, the manufacturers of the Ethernet devices have created interfaces, converters that will take DeviceNet or Profibus or whatever and convert it to Ethernet IP.
That's good.
So it's like a protocol translator, basically what it is.
Some of that technology predates, the Ethernet cables.
Oh, yeah.
That's why-
Oh, really?
Yeah, DeviceNet was coax.
No kidding. That's something we do every day.
Okay, so as it says here, legacy Rio networks, communication systems, and industrial automation that connect remote devices like sensors and actuators to a central control system. Typically, the networks predate modern Ethernet systems and use specific protocols. So, I think they're all pretty much pre-Ethernet. How do they work? Very carefully. Most Rio networks are kind of a master-slave thing. The controller is the master, and it says, hey, remote device, what is your pressure, temperature, whatever it is. And conversely, it says, hey, actuating device, open, close, raise, lower, whatever. PLC acts as the master in most cases. Some, like the SLIC controllers, you had what was called a Rio scanner, remote IO scanner. It was a two-wire system. You had signal and ground, and that was the only two wires. And well, there was a shield that went along with it to protect your remote information from electromagnetic interference, EMI. But the Rio scanner would go to the first device and say, hey, what is your temperature, pressure, whatever. They would report back and then go to the second device. What is your value that I need? They would report and go to the next device and so on. And they would do that on a round robin kind of thing. So
Rio, doesn't it have, like you have to, like you said, that proper cable termination, if you, don't that type connection causes like where information collide and has to use collision?
well, that's why it's master slave. You have one guy asking, it's a polling thing. Hey, what's your name? Hey, what's your name? Hey, what's your name? Hey, what's your name?
Oh,
What's your temperature? What's your pressure? What's your flow rate?
It's asking one at a time.
Yeah. The problem with that though is the more devices that you add to a Rio network,
The slower.
the slower it gets, exactly. Because, I asked Drew and he tells me, then I gotta go through 18 other people before I get back to Drew so I can ask him again.
mm-hmm.
That is probably gonna happen fast enough that whatever Drew is reporting is not going to change significantly. From by the time I get back to him for it to be a problem. But if we have every room in this building full of people and I have to ask them one at a time,
Take forever.
by the time I get back to Drew, he may be, 400 pounds over pressure and it's just gonna start blowing up.
Yep. True.
Okay. each device has remote, unique, or that. Each device has a unique address and communication is sequential. So there's the problem, one at a time. Okay. Rio networks have limited speed, bandwidth, and device capacity. Proper cable termination and shielding are crucial for stability. On a Rio network, many of them at the start, well, sometimes at the start and almost always at the end, occasionally start end to end, there is what they call a terminating resistor.
Oh.
That you have to put in, and the value of that resistor is dependent on the number of devices that are connected to the Rio network.
Oh, my.
So if,
Like a
you know,
bus.
if you add one or two devices, subtract one or two devices, you can probably get away with the same resistor, but if you add, you know, a whole nother line, say, you know, you expand your plant and you add a whole nother line, and you're adding dozens of sensors, and they're all on Rio, you're definitely gonna have to update the value of your terminating resistors, because you'll do all kinds of wonky things to the network if you don't. You'll throw the impedance off on the network. And you'll start getting data errors
Yeah, we don't want wonky.
on, not just on the device that you have, but on everything on the network, you start getting errors.
Everything goes wonky.
Yes. While largely replaced by modern networks like Ethernet IP, Rio is still found in older systems. Like I say though, fortunately, they do make converter devices that will switch from the older protocols to Ethernet IP. The one that I can think of that, well, I guess technically it still does. You have two different kinds of Modbus.
What?
You have two different kinds of Modbus.
Okay.
Modbus is a protocol that is specifically designed and built by Modicon,
That didn't tell me.
which was, well, they were the first people that,
Did this?
no, they were the first ones to invent PLC.
Yeah,
Oh, okay.
and they used it for.
Dick
their
Morley
PLCs.
was the father of the PLC. Think back to PLC 1.
That
Many moons
was,
ago, Drew.
that was.
That's
wild.
Schneider now, right?
Yeah, they're owned by Schneider Electric.
Schneider Electric.
Oh, okay, I've heard of Schneider Electric, okay.
Yeah. So Dick Morley was the guy that, well, he came up with the concept of the PLC, and then he and his team created the PLC, and they started Modicon. I don't remember off the top of my head what Modicon's, you know, where they got the name, but
This must be-
Modicon then decided that, hey, we need to be able to communicate with other devices, and we need protocol. There weren't any, so we had to invent our own.
Yeah, really.
Is it like
That's
the
good.
8485 or something?
No,
Or is,
Data Highway is a Rockwell thing.
oh,
So when did this Modicon all start out? Back in 85, somewhere like that?
It was in the early 80s.
1979, apparently.
Okay, late 70s.
So they were really early.
Yeah.
But back then, if you wanted to do anything, you had to write your own protocol.
Pretty much.
Pre-Windows 95.
Mm-hmm.
Pre-Windows 95.
When I was in college many moons ago, we actually had Modicon hydraulic robots
No kidding.
in a robotics lab. So,
I bet that was.
It's hard to even picture computers being around back then. Like, I wasn't around back then, obviously. It just, Windows 95 is about my earliest memory of computers.
Well, computers,
Yeah,
computers took a whole room back then.
I'm older school than that. Drew's a little bit older school than me, but you know, at least we're both post UNIVAC systems.
Yeah, back then you used the punch cards and, there was a whole room for your computer.
That's,
You put in your punch cards and you came back at the end of the day and you grabbed your program because it took all day for it to process your thing, because there's always a line of people wanting to put in punch cards. It was hard.
Yeah, when did you join military?
I joined the reserves in 81, joined the active army in 88.
Okay, so you were microcomputer era.
I didn't get a computer until like 93, 94.
Well, you were still microcomputer era.
Well, they used typewriters in my era.
Well, yeah, I understand that, but the microcomputer was already a thing whenever you joined the military.
Yeah.
They still had a lot of the old.
when the Apple II came out,
They had a lot of the old, room-sized computers still because,
Oh, yeah.
you know, they want to use everything for as long as they possibly can before they have to upgrade or update.
Yeah. Yeah, we still use big room. Back then, when you got a computer, you got the program with it, and little bunch disks, so you had to load the operating system when you started first loading the computer.
Back in the day, the old original IBMs, they had big, real tape drives on them.
Oh, I believe
That
it.
was the only form of storage they had.
back when IBM still made stuff.
Yeah.
It
Yeah,
was called Big Blue.
IBM was
Back
the
when IBM
man
was
back
the
then.
Yeah, they were, Big Blue.
Big Blue, they were the man. You wanted something with a computer, you went to IBM.
Okay, so, network topology. Rio networks typically use a bus or a daisy chain topology.
Oh, really?
These setups, devices are connected in linear sequence, starting from the central controller and extending to remote devices like sensors and actuators. Linear structure simplifies wiring and installation, but may have limitations in flexibility and fault tolerance compared to modern network designs.
No kidding.
So, if you have, you guys know what daisy chain means?
Yes.
Yes,
Okay.
jumper connection, or
Basically, yeah. So that's your scanner. And then pretend like that line is straight, right?
So we'll go with that.
That's really straight.
And then you tap off of it and go to the individual field devices.
And you have to have a resistor at the end.
Yes, haven't gotten that far yet. You tap off, go to the individual field devices.
Mm-hmm.
That's a bus network.
one fail, all fail, right?
Yeah.
Well, if the backbone fails, then anything downstream of it is definitely going to fail. Things upstream of it are probably going to fail because it's expecting the terminating resistor that is down here
Not there.
that's not there anymore because the line's broke. Okay? The other option is daisy chain. Where you go in and back out, in and back out of every device.
Which is almost as bad.
Yeah, if this connection breaks for whatever reason,
Everything there is
and
bad.
downstream of it is still dead.
Makes it easy to troubleshoot.
Yeah,
Go to a computer.
Most of the time.
Either works or doesn't work. If it doesn't work, you know.
the problem with, daisy chain though is, with Ethernet, everything's done typically anyway on a star or tree topology.
Mm-hmm.
You just plug in another cable and you're good to go. With these guys, you have to physically break the connection, put in the new device, and reestablish the connection on down the line. So, you can't just plug in a new device and be done. you had to schedule when you were going to do the installation, because if you needed to add this device here, you're going to kill everything downstream of it.
Mhm.
And, you know, if you were trying to run active production and you killed 2/3 of your network because you added a device, you know, you got problems.
Big problems.
So these topologies are rarely used probably
Anymore, yeah.
anymore. The only way you probably run into them if you're integrating a newer device system into that topology.
Yeah. And you would typically break it one time.
Yeah.
Put in the immediate converter and go from device net or whatever to Ethernet and be done with it. Wait, no, I was talking about Modbus, wasn't
Mm-hmm.
I? There are two kinds of Modbus. You have Modbus RTU, which is serial communication,
Mm-hmm.
and then Modbus TCP, which operates over Ethernet. With Modbus RTU, every device has its own unique address, and they are in a daisy chain style network. With Modbus TCP, everything still has its own unique address. It happens to be an IP address, but it's in a star topology.
Much better.
So you can add and subtract as needed. Okay. Communication protocol. Protocols establish the rules for how data is structured, transmitted, and interpreted between devices. These protocols ensure that data is consistently formatted, allowing devices to accurately understand and respond to transmitted information. Standardization is essential for seamless communication and coordination across the network. Reason why I can stand up here and talk and you guys understand what I'm talking about most of the time.
Some of the time.
Yeah, we'll go with Drew's, some of the time.
Some of the time.
Is because we both understand American English. Okay, data exchange and real-time operation. Remote I/O devices send data such as sensor readings, actuator signals, whatnot, to the central controller over or across the Rio network. Real-time operation ensures data transmission and device actions occur within precise timing constraints for automation. To a certain extent, I said, you know, the more devices that you add to a Rio network, the slower it becomes.
Mm-hmm.
Primarily because you have more devices to talk to and get information from or give information to, but it's also limited by the amount of bandwidth that is available to those older systems. You know, nowadays we get 10 gigabit pipes that, you know, to our house,
Mm-hmm.
and
Can't
you know,
use all of it.
back in the day there was no, they couldn't have even fathomed 10 gigabits a second.
Oh, the gamers loved it.
Integration with control systems. Legacy Rio networks connect remote I/O devices to central PLC or DCS. We haven't talked about DCS yet, but DCS is a distributed control system. We'll get more into that.
Distributed control system.
Yeah.
Okay.
We'll get more into that a little later in the semester. They pull the remote I/O devices for data and send control signals, enabling distributed control over long distances. The one advantage that Rio has, I guess, reason why it became popular, especially in process control systems or large campuses like refineries and that kind of thing. You didn't have to have a dedicated controller at every machine.
Yeah, you could just sit there at your
No.
computer and watch all this stuff.
Well, you can still do that today.
Well, I mean, you can do that, of course, today, but
Right.
back then, that was
The-
amazing.
Yeah, well, the neat thing about that is instead of having to spend the money for a whole controller, for every piece of equipment, you would just put to connect the sensors and actuators to a Rio, and then you had one cable that went back to the controller.
Oh, okay, well, that's cool.
So,
It's
you know,
the
if you had
remote
a,
IOs, right?
yeah,
Kinda like a remote IOs.
it's exactly what it is.
Oh,
Yeah, that's pretty
what
swift.
Rio is remote
remote
input
IOs.
output.
Oh, yeah, they should know about this, right? Or they haven't got there yet?
No,
Oh.
short answer is no. Anyway, if you have a dozen sensors on a piece of equipment, you have to get a dozen signals back to the controller. Well, do you want to run a dozen different cables,
Oh, hell
one for
no.
each sensor, or do you want to run one cable that carries all the signals?
Just one cable.
One cable. Okay. That's where the beauty of Rio comes in, is you can have, you know, within a reasonable distance anyway. Otherwise, you have to start adding in signal repeaters and things like that. But you can have a relatively large campus that you can control. You know, you buy one controller and you do everything on remote I/O, so you only have to run one cable to each machine.
That's pretty
And you
cool.
get all of the data and send all of the actuation signals on one cable. A lot cheaper to run, a lot cheaper to purchase because you're only buying one cable instead of a bunch of them. There's a whole host of reasons why remote I/O is a good thing.
A lot easier to maintain too.
Yeah. Especially nowadays, whenever you can do everything over Ethernet, because if you had to do everything on a bus or
Oh, that's a
daisy chain network, then you had your main cable ran out and you had to jump from device to device on that machine.
You have to have power in the cable.
Well, the power was typically at the device itself. All you had to have was communication. They had to have common ground signal,
Oh, I don't
not a common 0 volt, but that was it. Anyway, you had to daisy chain everything together on a piece of equipment. Whenever you get back here to the scanner at your control device, each machine is a separate channel on your Rio scanner.
Uh-oh. That means you have to program it.
Well, it also means that you have to have a separate cable to each machine or each device. It comes back to the Rio scanner, and these have limited number of channels per scanner, depending on
I can believe it.
what you're talking about. Examples of legacy Rio, a lot of them we've already talked about: DeviceNet, Profibus, ASI, and Interbus. Interbus is proprietary to Phoenix Contact. I don't know if they do now or not, but it used to be they wouldn't license their technology to anybody else. So, you don't have that interoperability between manufacturers. You go Interbus, it is Phoenix Contact, period.
So like the vendor handles all the maintenance.
Well, no, you couldn't go to Banner or Keyence or anybody else and buy an Interbus device.
See,
If you wanted Interbus, you had to buy from Phoenix. Yeah, proprietary. For a long time, Rockwell refused to sell Ethernet IP to anybody because they knew that they had something there. They wanted to be the top dog, and then they decided, oh, wait a minute, maybe that's not such a good idea, because if we do that, we're gonna basically shove ourselves out of the market because there are other, like Modbus and device network, which is also a Rockwell invention. And a bunch of other protocols that are universal, if you will, licensed to, everybody wants to, if the license isn't cheap. But if I wanted to make a device net device, all I have to do is say, hey, Rockwell, I want to use the device net protocol, and they say, okay, give us money. Okay, you gave us money, here, we'll let you, here are the specs for this protocol. Cabling, signaling, timing, and all that stuff. Characteristics and considerations. Compatibility. That's probably the most important one right there.
Yeah.
Each protocol requires specific hardware and software configurations for interoperability with automation equipment. Maintenance, just like everything else, regular maintenance, minimizes downtime and ensures reliable operation. Migration to modern systems. Many companies are transitioning to Ethernet-based solutions for improved data rates and cybersecurity. I'm not sure that I agree with the cybersecurity part of that because
Yeah, because it's.
those old networks, if you tapped into one, managed to tap into one, all you would get would be, sensor data from a machine, okay, so it's running at 300 PSI, whoop-de-doo. You couldn't use it to get into.
You can use it as a backdoor.
Yeah, you couldn't use it as a gateway into anything that, was of any consequence. To speak of, I guess you could inject false control signals in and, tell the cylinder to extend and retract at the same time, which if the logic was written correctly, it knows it can't do that. So you may be able to stop production that way,
So
but
that's as far as you could go.
yeah,
Or you could go.
it's not like you could get into, accounting and clear out the bank account or anything from a real network. It just wouldn't happen. So, in summary, legacy Rio networks offer robust real-time communication for connecting remote devices in industrial settings. However, as technology advances, there is a shift toward Ethernet-based solutions for higher data rates, better integration, and enhanced cybersecurity. That's the problem with Ethernet, is you have to secure it from outside influences.
Like a physical, someone coming into physical.
Yeah, if you can compromise the Wi-Fi on a machine, which a lot of them do have, instead of running that cable from point A to point B, put it on Wi-Fi. And if you can hijack that signal, which you guys learned last week is totally doable.
It's just a radio signal.
Yeah. It's an encrypted radio signal,
Encrypted
but
radio
it's
signal.
still
Still a
just a
radio
radio
signal.
signal.